Let's start with a really wild idea. What if numbers aren't just these static things we use for counting? What if they're actually alive, with their own hidden architecture? That's the mind-bending concept at the heart of a theory called numerical resonance.
I mean, really think about that for a second. We use numbers all day, every day, but this theory asks us to imagine that behind that simple facade, there's a whole secret world. A world full of patterns, relationships, and maybe even personalities.
And here it is, the idea that just flips everything on its head. This theory, sometimes called the Zarazita resonance model, suggests numbers have properties we've never even thought to look for, like a unique arithmetic spin that could actually define how they behave.
Okay, so if numbers have this hidden world, how do we even begin to see it? Well, the first tool we need is something the theory calls the 36 modular clock. You can think of it like a special compass for navigating this new, unseen landscape of numbers.
So you're probably wondering, why 36? Seems a little random, right? Well, according to the theory, it's not random at all. 36 is this perfect number because it beautifully combines the powers of the first two primes, 2 and 3. See, it's 2 squared times 3 squared. This makes it the ideal prism to split numbers open and see their hidden colors.
And this is where it gets really interesting. Every single number, it doesn't matter how good, gets a specific address on this 36-point compass. When you do this, a stunning pattern just emerges from the noise. It turns out that all prime numbers, except for 2 and 3, can only live in 12 specific spots on this clock. It's this hidden order that was there all along, we just weren't looking at it the right way.
All right, so once a number has its address on the clock, we can start to do something really cool. We can decode what the theory calls its DNA. And this DNA is made up of two key properties, something called core 0 points and its own unique arithmetic spin.
These so-called core 0 points are described as resonance points, kind of deep inside a number's structure. The theory suggests that the number of these points is what determines how stable a number is and what its job is in the whole system. It's a completely different way of thinking about what makes a number strong or weak.
Now check this out. It's how these points combined that's so fascinating. So the primes 5 and 7, they each have 8 of these core 0 points. But when they multiply together to make the semi-prime 35, their points don't just add up. They combine into this field of 16 points. The theory calls it a harmonic superposition that gives 35 this whole new, more complex structure.
Okay, this leads us to a really interesting puzzle. If this 36 modular clock gives every number an address, what happens when two totally different numbers end up on the exact same spot? How do you tell them apart?
The answer is arithmetic spin. Get this, both of these numbers, 24,257 and 28,757, land on address 29. But their guts, their prime factors, give them completely different personalities. The theory calls one a metronome, like a fast oscillator that interacts with other numbers super quickly. The other one is an ondecker, or discoverer, a slow rotator that explores the numerical world more carefully. Same address, but totally different jobs to do in the ecosystem.
So, we have a map, we have a number's DNA, but what makes this whole system dynamic? What makes it go? This is where recursion comes in. The theory describes it as the actual heartbeat of the system, a process that shows how numbers evolve and reveal who they really are at their core. The best way to think about this is like methodically peeling an onion. You're stripping away a number's outer layers one by one. By applying a specific filter over and over again, you can boil any number down to its fundamental essence, what the theory calls its arithmetic backbone, and a final value known as its end key. So here's a super simplified look at how this works. You start with any number, let's call it x. Then you apply this stroboscopic filter. Basically, you find the biggest power of 2, that's the n in the formula, that when you multiply it by 3 still fits inside your number. You subtract that chunk, and what's left over, a, becomes the first piece of the number's hidden identity. Then you just do it again and again, breaking the number down step by step until you've revealed its entire secret family tree.
Okay, so what is all of this for? Is it just a cool mathematical curiosity? Well, according to its proponents, this architecture could have some massive real-world applications. Everything from creating unbreakable codes to, maybe even explaining the fundamental harmony of the universe itself.
And this is the big one. This is the practical claim, a brand new type of encryption that uses this entire resonant architecture. By understanding a number's spin,
its recursive history, and its address on the clock, the theory says you can create a code that is, and I quote, relentlessly powerful. And here's why it's supposed to be so tough. Cracking it would mean doing so much more than just finding two prime factors. A would-be attacker would need to figure out how many times it rotated on the 36 clock, what its unique spin vector is, and its entire recursive history. You're not just trying to crack a number, you're trying to decode its entire life story. Good luck with that.
And then, finally, the theory makes its most audacious claim of all. It actually proposes a solution to one of the biggest unsolved problems in all of mathematics. It suggests that those mysterious non-trivial zeros of the Riemann zeta function, they aren't random at all. Instead, they are the exact synchronization points that hold this entire system of numerical resonance together, the very things that guarantee its stability.
Which leaves us with this final, absolutely staggering thought. If any part of this view of numbers is true, if they really do have an internal structure, a rhythm, a DNA, a spin, then it suggests that the fundamental laws of the universe might be written in a kind of harmonic resonance, a cosmic code that we are only now, maybe, just building the tools to finally hear.